Hi there, this is Science Lady for grade 11 and 12 chemistry. Today we are doing fertilizers, the complete summary. Subscription to the Science Lady channel is free, so subscribe and click notification. Please note that the exam guidelines in caps are followed. The complete summary on fertilizers can be done on a double folio paper, so go and get your paper ready. In this video, I discussed the topics or concepts regarding fertilizers that are required to be learned. Therefore, listen carefully so as to write down correctly. Use this video when you do revision. Pause after every slide to see how you can recall. Plants absorb sunlight, water, and carbon dioxide from the air, and the salts of nitrogen, phosphorus, and potassium from the soil. Fertilizers are used in the commercial production of food. This chapter falls under the category of inorganic chemistry. The fertilizers we discuss are the salts of nitrogen, phosphorus, potassium, as well as sulfur. Salts will then be called nitrates, phosphates, potassium, and sulfates. Potassium is also called potash. Here are some examples of inorganic fertilizers. Ammonium nitrate, NH4NO3, ammonium sulfate, brackets NH4, close the brackets 2, SO4, ammonium phosphate, brackets NH4, close the bracket 3, PO4, and potassium chloride, KCl. It is also a requirement that you must distinguish between macronutrients, C, H, and O, primary nutrients, N, P, and K, and secondary nutrients, Ca, Mg, and S. Organic fertilizers are nature's fertilizer. For instance, compost, animal manure, and seabird or bat guano. This is an alternative for the inorganic fertilizers produced in the industry. Urine is high in nitrogen and can be used as a fertilizer. But in the industry, they produce a product called urea, CO, brackets NH2, close the brackets 2, because of its high content in nitrogen. The usefulness of nitrogen, potassium, and phosphorus as fertilizers. Nitrogen makes protein and chlorophyll. Shortage of nitrogen causes yellowish plants and prevents good growth. Potassium increases a plant's resistance to disease and improves the yield and quality of the fruit. And phosphorus is necessary to make nucleic acids. A shortage of phosphorus causes small seeds and no ripening. This is how to calculate the percentage fertilizer, which is N, P, and K in a bag of fertilizer. For example, if the bag mentions 8 to 1 to 5 and in brackets 25%. This means that 25% of the bag contains nitrogen, phosphorus, and potassium. So how do we go about doing this? First, add together the numbers 8 plus 1 plus 5, that gives you 14. Then for each, calculate the percentage. So it's 8 over 14 times 25 equals 14.29%. 1 over 14 times 25 equals 1,79%, and 5 over 14 times 25 equals 8.93%. The remainder, 75%, consists of soil and other micronutrients. Study this well. Eutrophication is a byproduct of the fertilizer industry. Now, what is eutrophication? It's the process by which an ecosystem, for example a river or a dam, becomes enriched with inorganic nutrients, especially nitrogen and phosphorus, resulting in excessive plant growth. If plant growth becomes excessive, the amount of dead and decaying plant material increases rapidly. You can see that there will be pollution in our rivers and our dams. So the disadvantages of eutrophication, you can mention two. There's the depletion of oxygen in water, and also the reduction in fish and other organisms in the water. The three very important processes in the fertilizer industry is called Haber Process, Ostwald Process, and Contact Process, and each one will be discussed separately. The Haber Process, some people also call it Haber. The Haber Process or Haber Process is an exothermic reaction where ammonia is produced. Now here is your reaction. So N2 plus 3H2 double arrow 2NH3. The energy will be delta H equals negative 92 kilojoules. We did say it's an exothermic reaction. Now N2 is obtained from boiling off in a fractional distillation tower, and H2 is obtained from the gasification of coal and steam. The Ostwald process is an exothermic reaction. There are three steps. Step 1, 4NH3 plus 5O2, arrow 4NO plus 6H2O. Please note the following, that NO is a clear gas. It has no color. And platinum, PT, is the catalyst. So the catalyst is used in the first step. We call this first step the catalytic oxidation of ammonia. Step 2. You use the NO from the first step. So step 2, 2NO plus O2, double arrow 2NO2. Please note that NO2 is a brown gas. Step 3, 4NO2 plus 2H2O plus O2, double arrow 4HNO3. Now please note that HNO3 is nitric acid, and it is used in production of fertilizers, explosives, and nylon. Go to the second column. The fertilizer produced from the Ostwald process is ammonium nitrate. So you will use ammonium and nitric acid. So it's NH3 plus HNO3, arrow, NH4NO3. Please note, NH4NO3 is an explosive in its pure form. Therefore, lime must be added to make it a fertilizer. It will then be called LAN, lime ammonium nitrate. The contact process is also exothermic reaction. Before we continue with the 4 steps, I first want to mention a few things, so let's follow the column in the right hand side. In this process, melted sulfur is burned in a furnace using air and producing sulfur dioxide, SO2. The SO2 gas is passed through a tower called the precipitator in order to remove the dust and other impurities which might interfere with the catalyst, and the catalyst is vanadium pentoxide, V2O5. SO2 can be obtained from 2 sources, either sulfur in its pure form, S, or iron pyrite, FeS2, which is also called fool's gold. The fertilizer produced from this process is ammonium sulfate, in brackets NH4, close the brackets 2SO4. So let's do the 4 steps of the contact process. Step 1. So it can either be S or FeS2 that is used. Let's do S first. So S plus O2 arrow SO2. Don't forget to mention the phases. In this case, SO2 is a gas. Or we can use iron pyrite, which is FeS2 plus O2 arrow Fe3O4 plus SO2. Step 2. 2SO2 plus O2 arrow 2SO3. Now this second step is the catalytic step. This is where vanadium pentoxide, V2O5, is used. Step 3, SO3 plus H2SO4, arrow H2S2O7. This H2S2O7 is called oleum. Step 4. H2S2O7 plus H2O will give you 2H2SO4. Please note that in step 3 you used 1 mole of H2SO4 in order to produce in step 4 2 moles of H2SO4. Enjoy! Study these slides well and use this video when you revise your work. Did you find the video helpful? Then please click the like button. Also subscribe, and you are welcome to ring the notification bell. Goodbye for now.